Cool. All right, welcome everyone to our presentation. We are Project Party Time. My name is Kyle, and the rest of our group includes Audia, Michael, and Danny. Next slide. So we'll be going over a few things in this presentation. We're going to recap what our project objectives were, and then we're going to be going over each individual aspect of design, including mechanics, electronics, software, and then finally we're going to be giving you some pathing demos for our robot arms. So to recap, the task of this project was to design two robot arms, one Bob, one Leo. Bob was going to perform a number of tasks, including painting a piece of Leo, cutting out a piece of Leo, and picking in places different components of a PCB. And finally, we were going to have Bob train Leo, or Leo learn from Bob in order to replicate a task. That task was going to be to press go on a boombox of some sort and to pour a shot of tequila. So now I'm going to turn it over to Danny for the mechanics.
Hi everyone, I am the mechanical lead, and I will be explaining to you the design of both of our arms. So both Bob and Leo were inspired from the UR robots, which are the universal robots, and are considered articulate robots comprising of only revolute joints, and both will be having 6 degrees of freedom. And on the right, you can see photos of how the UR robot looks like in real life, and then on the left are photos of our designs. Next slide, please. So here is a in-detailed CAD drawing of Leo, and these numbers on the left show where the motors would be at. And so there's 6 for the 6 degrees of freedom. In the middle, we have the dimensions. And on the right, we have a zoomed up view of the robot from the top of dimensions. Next slide, please. And on this slide, we show Bob. The motors aren't labeled here, but it's basically the same concept. There's one at the base, one right here at the first joint, and then so on and so on. At these little cube cylinders, there's supposed to, theoretically, would be a motor there. And also the dimensions for Bob as well. Next slide, please. So inside the joint, theoretically speaking, if we were to be doing this in real life, we would be having a motor attached to a gear train at each one of the joints. And all of these motors would be controlled through the controller. And I got these photos from a article called A New Approach to Design of a Lightweight Anthroponophilic Arm for Service Applications. Next slide, please. So here you can see the DH parameters for both Bob and Leo, and on the right, there's the joint schematics. And so these DH parameters were derived from the resting states that they are in the CAD drawings in the slides before that we saw. And so with these DH parameters, we can see, we can obtain the forward kinematics and the inverse kinematics as well. Next slide, please. So the inverse kinematics was derived from this matrix equation right here on the left, and the inverse kinematics from these equations on the right. And both of all these equations were obtained from the NICU book. Next slide, please. On this slide, we show Leo's forward kinematic matrices. And next slide, please. And here we show Bob's forward kinematics matrices. And next slide.
Cool. So hi, I'm Michael. I'm the electrical lead for this project. Next slide, please. So here, as shown, is the block diagram. This will allow Bob and Leo to accomplish their objectives. There will be a predetermined location of where the tequila bottle, the shot glass, the boombox will be. The path planning code will then allow the arm to move in the direction it needs to be. At the set destination, the end effector will then do the task of either cutting, painting, the pick and place, grasping the tequila bottle, and then pressing play on the boombox. This will be accomplished by having like proximity and force sensors, which would utilize to set areas to let the robotic arm know when and where to start and stop. Next slide. Excuse me. So both Bob and Leo will need electronic components, of course, to operate. The force, of course, will be the power supply or the power source. They'll have like 6 servo motors corresponding to the arm, the elbow, and the wrist, and will operate all in 6 degrees of freedom and be able to move each joint to achieve the desired objective. It will also have 6 joints, and each joint movement will have a certain range. The PC control software, like Danny mentioned, will be the controller and will send the control commands to the steering gear, and in order to achieve the accurate arm and in-space operations. Theoretically, both robots, Bob and Leo, would be controlled using a pre-programmed movement, and I'll pass that along to Adia.
Okay, so I'm gonna be talking about the software. I'm Adia, I'm the software lead. All right, so the code, we still continue to try to use Python as much as we can. The whole goal was to use it to pre-program Bob to be able to complete all the tasks that we wanted, which was like the cut and place, the pick and place, and our chosen actions to teach Leo. And then we also want to have the code for Leo be pre-programmed to just mimic and use a sensor to mimic Bob, just so that way it's almost like a copycat kind of code. So like I said, our desired methods were just to do the cut and place, pick and place, and teaching. And I believe we were also trying to attempt painting as well. So we just wanted to make sure all like the movements were as clean as possible, and just have like the shortest path, which also did not end up working when it came to the Python planning. We did struggle a bit trying to get the Python to work with our codes. So in the end, we ended up mainly using path planning. So that way, that was easier just to do like some of the ease moments. And through going through like the Python codes, a lot of the times it was easy to connect them to make sure they would work, but we came across a lot of errors in trying to implement it in VREP. So in trying to connect them together, it wasn't reading the way it was supposed to. So some of the things was just making it spaz around. So we are not going to add like that video onto here. So most of what we are going to present today is going to be most of our pathing. So so a lot of like our struggles was also trying to figure out like which gripper to use and our end effectors as well. A lot of the times I was trying to figure out how to connect it, and that took a little while, and then try to figure out what gripper would work best with each scenario. For the most part, we went with this, oh my gosh, I forgot the name, but we went with this gripper here in this picture. So that way we were able to, so with, at least for Leo, we wanted to have him learn how to press, and we ended up using a record player with a push button, so that way we can play the song Tequila using the Python code. So once it was on, it'll just automatically start playing the music. And then we also wanted him to be able to mimic grabbing a tequila bottle and pouring a shot, even though we weren't able to try to incorporate using a record player. We ended up just using using it for looks mainly. And then for the bottle, we were just using it for the bottle. We couldn't add liquid or anything like that to make it more realistic in the situation, as we were originally trying to plan to do. So in that case, we needed a gripper that was big enough to hold on to the bottle and then close, so that way we could just press the button, so that we wouldn't have to worry about transferring it out as well. So we do have videos for our successful planning pathing demos, which would be our pick and place and the push button of the record player. So we'll go ahead and show that right now. All right, and then here we have our pick and place one. So here we have the RG2 gripper as well. So I'll go ahead and play this for you. Oop. So this is the design we are using for our pick and place. We didn't add anything for the pick and place here. We were mainly we were more worried about getting the pathing correct. So this is what we have for that one. And then here is our final simulation that we were going to show you guys. So here, let me go ahead and slow it down a bit. So here you can see our robot. This one's using the Barrett hand. So this one was also, as I was explaining earlier, to help grab like the bottle, but we did not get that far in this. Right now, we just have him pressing like the play button for the record player. But as stated before, it is separate to what we have. We just have it for more for show than we do for practical use, which is why we put in that button, in which we were planning on trying in the Python code to be able to, once it was pressed, play the song Tequila. So that way, as the song is going, we can do the display for the recording of the shot. But like I said, because of all the issues we were having with Python, we didn't end up having that work entirely.
So those concludes our demos. Here are our references. So that's basically all of our presentation. Like was stated earlier, we were unfortunately unable to complete the actual picking up and placing of the PCBs as well as the painting because we kept running into issues with our grippers and other end effectors. However, we were able to successfully, code the path planning into our robots to be able to maneuver them into the correct locations. So otherwise, thank you very much, and please leave any questions you have in the chat.